In the past two lessons, we've done very different types of testing with ratio or interval data. We used the t-test and ANOVA to determine whether we should accept null hypothesis when comparing means. The t-test was used to compare two means between either non-paired or paired data. A one-way ANOVA was used to compare more than two means between non-paired data. And a repeated measures ANOVA is slightly different and is used to compare more than two means between paired data and was not covered in this course. In the next lesson, we didn't compare means, but looked at the relationship between variables to determine if they are correlated, and we used the Pearson-R test. The Spearman-Rowe test can be used if one or both of the variables are ordinal. If there's a strong correlation between two variables, a regression equation can help us predict the value of one variable when the other is known. Take time to pause and review this slide and make sure all of the information makes sense to you before continuing. Previously, this slide was presented to differentiate between parametric and nonparametric statistics. The basic difference is that in parametric statistics, the dependent variable is a measured quantity, a ratio or interval variable, so it makes sense to calculate means and standard deviations, and these types of variables are analyzed using parametric statistics. With nonparametric statistics, the dependent variable is usually either a count or ranking, an ordinal or nominal variable, such as the number of persons cured of a disease. It makes no sense to calculate means. For example, the average cure is 34.6. Therefore, these types of data must be analyzed using a nonparametric approach. A nonparametric approach is also used when the data do not represent a normal distribution. Here is a table I've constructed that has similarities to the table in your text, comparing the hypothesis testing used in parametric versus nonparametric situations. In comparing two groups with ratio or interval data, we learned to use the independent or non-paired t-test and the dependent or paired t-test, determined by whether we had non-paired or paired data. When comparing the ratio or interval data of more than two groups, we learned to use a one-way ANOVA for independent or non-paired data. We would use the repeated measures ANOVA for dependent or paired data, which was not covered in this course. If we test data that are nominal or ordinal in nature, or which don't represent a normal distribution, we must use different statistical analyses. The tests we will cover in this unit are the chi-square to test independent nominal data in two or more groups, the Mann-Whitney-U to test independent ordinal data in two groups, and the Wilcoxon-signed ranks to test dependent ordinal data in two groups. The Niemer test used with nominal dependent data, and the Kruskal-Wallis H and Friedman test used with ordinal data of more than two groups will not be covered in this course. The chi-square test is used with independent or non-paired data with two or more groups that are nominal variables. It is used to analyze frequencies or proportions. It is a non-parametric test used to determine if a distribution of observed frequencies differs from theoretical expected frequencies. Let's use a simple example. In tossing a coin 100 times, you get 47 heads and 53 tails. Of course, the null hypothesis and the expectation would be that there would be no difference, and you would get 50 heads and 50 tails. Heads and tails are nominal variables, and we just want to see if the frequency of heads versus tails is equal. The formula for chi-square is to do a summation of the squared difference between the observed and expected outcomes divided by the expected outcome. You can see how this is done to receive a chi-square value for our example on this slide. Then you can use that chi-square value to check in a table to see if the result is significant and whether we should accept or reject the null hypothesis. Let's check this example using an internet resource. Go to the website listed at the top of this screen. We will not be entering more than 20 categories, and we will enter the expected values as the actual number, so these can remain in the default choices. Enter the data as I've shown on this slide, and then select Calculate Now. For the category entries, I've entered a 1 for heads and a 2 for tails as the website only allows a number for the category. Due to a p-value of 0.5485, the difference is not considered significant, and we would accept the null hypothesis. 47 heads and 53 tails is not a significant chance result from 50 heads and 50 tails. Let's do one more example using this website. The blood types and percentages for the U.S. population are shown on this slide and would represent our expected values in a sample. The blood types and percentages are shown for a sample drawn for a particular study. I entered the data as shown on this slide and selected Calculate Now. Again, I substituted numbers for blood type in the category column. 1 for type A, 2 for type B, 3 for type AB, and 4 for type O. As the resultant p-value is 0.0001, we would reject the null hypothesis. Our sample is quite different from what was expected. The Mann-Whitney U-test is used with independent or non-paired data with two groups that are ordinal variables or do not represent a normal distribution. It is similar to the independent or non-paired t-test in that it tests the null hypothesis that there is no difference between two groups of scores or rankings. Here is an example of a study where ratings are used on a scale of 1 to 10 with two different groups of subjects. Therefore, the variables are ordinal in nature, and to compare the two groups, we must use the Mann-Whitney U-test. Pause the presentation and take time to read about the study before continuing to the next slide. When the rankings from the three judges are averaged for each subject, these final ratings are obtained. Go to the website listed at the top of this slide. This is an internet resource for being able to complete a Mann-Whitney U-test. The first item that shows on the screen is a prompt for the number in each sample. If one sample is larger than the other, enter the larger sample number in this first screen. In this example, the larger sample number is 11. Do not press Enter on your keyboard after typing in the number. You must click on the OK button. Then, a second prompt will show for you to input the size of the second sample. In this example, I've entered 10. Enter the number and select OK. On the next screen, scroll down and enter the data in this form, and then have the program complete the statistical calculation. The data we have are entered as raw data on the right-hand side of the form. Then, we choose Calculate from Raw Data to get the statistical results. We always use the p-value represented for a two-tailed test, which in this case is designated by p equals 0.091. As the p-value is greater than 0.05, we accept the null hypothesis, indicating that there is not a statistical difference between the two groups. The Wilcoxon signed ranks test is used with dependent or paired data with two groups that are ordinal variables or do not represent a normal distribution. It is similar to the dependent or paired t-test in that it tests the null hypothesis that there is no difference between two groups of scores or rankings from paired data. Here is an example of when to use the Wilcoxon signed ranks test. Note that in this case the variables are not ordinal, but racial. However, the nonparametric test is used as the data do not represent a normal distribution, since only obese individuals were chosen for the study. Pause the presentation to take time to read about this study. Here are the data representing the weight of each subject before beginning the new diet and 6 months after being on the diet. Go to the website listed at the top of this slide. You will initially see a pop-up box asking you to enter the number of subjects in the study. In our example, there are 12 subjects, so we enter 12 and then select OK. We enter the data in the data cells on the left-hand side of the screen after scrolling down to this table. Then select Calculate. You will see that the p-value is 0.0024. As this is less than 0.05, we will reject the null hypothesis and suggest that this was a successful diet. This completes the presentation on nonparametric statistics and the use of chi-square, Mann-Whitney U, and Wilcoxon-Signed Ranks tests. Take time to go back and review the presentation as needed.